Hi everyone, this video is on the challenge question of mixed exercise 9. In the previous video, I solved questions A and B, and in this video, I'm going to do part C. And in the next video, I'm going to do the final two parts. So, in part A, we obviously found dy by dx in terms of t, which is written here. And then in part B, we found the coordinates of the points on C where dy by dx is equal to 0. Or in other words, we found the stationary points, which was quite long actually. We had 4 stationary points, as you can see. These are the stationary points. Okay, now for part C, we want to find the coordinates of any points where the curve cuts or intersects the coordinate axis and determine the gradient of the curve at these points. So basically, we want to find the x and y intercepts in part C. Okay, so obviously this is just some maybe a standard questions, and I think it's not challenging in the sense that the question is challenging, but it's just more like we have just some very long calculations, and especially a lot of substitutions, trigonometric equations. So the questions are just long in this challenge question. They're not really challenging. Anyway, so in part C, we want to find the x and y intercept. So first of all, let's just start with finding the y-intercept. So if you want to find a y-intercept, we need to remember that at y-intercept, x is equal to 0. So when x is equal to 0, the x-coordinate is obviously 0 when the curve cuts the y-axis. So if we want to find this, we also need to go back to the equation that we had at the beginning, because we want to find a y-intercept. So what we are going to use is the equation of x, obviously, because again, at y-intercept, the value of x itself is 0, the x-coordinate is 0. So that's why we use the equation of x, because we can solve this equation and set the equation equal to 0 and find the values of t for which the x-coordinate is equal to 0, and then we can substitute those values of t to get the corresponding y-intercepts. Okay, so with that said, we are going to use the equation x is equal to 5 cos of t plus pi over 12 and solve that. So we can say when x is equal to 0, this equation 5 cos t plus pi over 12 is equal to 0. Now let's solve this trigonometric equation. Obviously, we can divide everything by 5 to get rid of that. And then if we do cos inverse of both sides, we are going to have t plus pi over 12 is equal to, remember that the range of possible values of t is that t is between 0 and 2 pi. So between 0 and 2 pi, there are basically two values that will make cos of the values equal to 0. So one of them is pi over 2, and the other one is 3 pi over 2. So these values have cos 0. And the next thing is obviously adding pi over 12 to both, subtracting pi over 12 to both sides, from both sides. So t is equal to 5 pi over 12 and then 17 pi over 12. Okay, now we have the values of t. We simply substitute each of these values into the equation of y, which was, remember that the equation of y is equal to 2 sine 2t. So yeah, we substitute each of these values to get the corresponding y coordinates. So this means that when t is equal to 5 pi over 12, then y is equal to, obviously it's going to be 2 sine of 5 pi over 6, and that's equal to 1. And also remember that what the question was asking was that, let's go back evolve, was that in addition to finding the x and y coordinates, right now we're finding the y coordinates, determine the gradient of the curve at these points. So obviously here the value of t is, we are using the value of 5 pi over 12. So we also need to find the gradient at this point when t is equal to 5 pi over 12. So we just substitute 5 pi over 12 into the equation of dy by dx to get the gradient. And if we do so, again, as you can see, just lots of substitution. So it's not nothing, mathematically challenging here. It's just a long question, and there is room for calculation error. So we will get 0.69 to 2 decimal places for the value of the gradient when t is equal to 5 pi over 6. Okay, so the next one is we can now take the value of 17 pi over 12 and see what happens. So for this value, the y coordinate is going to be, again, it's going to be equal to 1. And then afterwards, we again substitute this t value into the equation of the gradient. And that's going to give us the value of dy dx as minus this 0.69 to 2 decimal places. So now the curve cuts the x-axis twice at the point 0,1. So this is going to be important later on for the final part, I mean. So basically the y coordinate is here, but again, this is going to be intersected twice. That's very important. So let's just write here to just have that twice, because we get this value obviously twice. And then the gradients are 0.69 and minus 0.69. Okay, so we have done half of the question. The next half, remember, was that we have found the y-intercept. Now it's the time for the x-intercept. So if we want to find the x-intercept, this time we set this equation equal to 0, which is 2 sine 2t is equal to 0, because for the x-intercept, the y-coordinate is equal to 0. So we want to solve this equation and find the values of t for which the y-coordinates are 0. So that's going to give us the x-intercepts. And then afterwards, we can find the gradient at those points. Okay. Now for the x-intercept, we can solve. So remember, when y is equal to 0, then we can find the x-intercept. So when y is equal to 0, then we can solve this equation of 2 sine 2t is equal to 0. So, and then let's divide both sides by 2. So we are going to get 2 sine 2t. Yeah, I'm just going to write this better. So 2 sine 2t. Yeah, if you divide both sides by 2, we'll get sine 2t is equal to 0. And let's do the sine inverse of both sides. So we're going to get 2t is equal to so here we should be careful, because we have 2t and the possible range of values of t is going to be 0 and 2 pi. But since it's 2t, then as we did last time, we first are going to find the values, the solutions to the equation, which are between twice of the range, which is going to be between 0 and 4 pi, because that way gives us the values of the 2t equation. And then afterwards, once we have found all of them, we are going to divide everything by 2, just to get back to the values of t, not twice of them. So in this case, in the range of 0 to 4 pi, the possible values of sine for which the value is 0 are going to be 0, then pi, then 2 pi, 3 pi, and then finally 4 pi. Now we find the values of t, so divide everything by 2. So it's 0 pi over 2, pi, 3 pi by 2, and then 2 pi. Okay, so these are the solutions to this equation. And all we need to do now is just substituting each of these values of t into the equation of x to get the corresponding x coordinates. And then we can find the gradient at each of these points, and then we are done. Again, another long question that is not challenging in any way. Just substitution, long substitution. So first, when t is equal to 0, then the x coordinate is 4.83, and then if you substitute this into the equation of the gradient, then we are going to get minus 3.09. So if you first substitute t is equal to 0 into the equation of x, and then into the equation of the gradient to get the x-intercept and the gradient. Right, now the next one is when t is equal to pi over 2, then what's going to happen is that the x coordinate will be minus 1.29, and then the derivative is equal to the gradient is equal to 0.83 to 2 decimal places. The next point is when t is equal to pi, and in that case the x coordinate is going to be this time is minus 4.83, and its gradient is 3.09. And finally, the last one, when t is equal to 3 pi over 2, and sorry, it's not, it's let's see, because I lost count of the coordinates. Okay, it's not the last one because we have also 2 pi. Anyway, so when t is equal to 3 pi over 2, then the x coordinate is 1.29, and then the gradient is equal to minus 0.83, and finally when t is equal to 2 pi, then the x coordinate is 4.83 to the decimal places, and then divide by the x is 3.09. Okay, so these are the gradients and also the x-intercepts. So for the x-intercepts, we have these values. So we basically have 5. Actually, not 5 x-intercepts, because for example, 4.83, we have basically just one intercept from that point, and then we have minus 4.83, and then 1.29 and minus 1.29. Okay, so these are the x-intercepts, and then for the y-intercepts, we obviously have only just 0, 1 basically. So where is that? Yeah, oh yeah, that's here. Okay, yeah. All right, that's it for this video. Thank you for watching.